Let's just take a few more minutes and go over a couple more problems for adding and subtracting rational expressions. So in our first problem, we have 6v squared over v plus 5, and we're adding 30v over v plus 5 to it. So again, we notice that the denominators are the same, they're already common, so once it's the same, it's going to stay the same. So I know I'm just going to have a v plus 5 on the bottom. And what are we doing with the top? We're adding them. So go ahead and just put everything together and put that addition sign in between the two terms. Now when we look at this, we might say, well, there's not a whole lot I can do. This is a trinomial. This isn't a trinomial, so I can't do trinomial factoring. But what can we do on the top? Well, we can do a GCF. Can't we factor out a 6 and a v from both of those terms? So both of these terms can be divided by a 6v. So I'm going to go ahead and put a 6v out front, and inside I'm going to end up with a v plus 5. So 6v, if you take 6v divided by 6v, the 6's will cancel out and you'll just be left with 1v. And then 30 divided by 6 will equal 5, and then v divided by v is just going to be 1. So now we end up with, so remember, if you can't do trinomial factoring, always look for a GCF. So that should always be in the back of your mind as a step that you can take to make the term simpler, and you might end up seeing something that can cancel out. Just like this, we have a v plus 5 on the top, a v plus 5 on the bottom. So we know that our answer is just going to be 6v. So again, the steps that we took to go through that, the bottom was the same, so we just kept it the same, and we kind of just took the two terms on top and kind of just put them together on the top. So we just took the 6v squared plus 30v and just kind of put it all together on the top, and we could easily see that there was a GCF we could factor out. So we did that. That was really the only thing that we can do, but it did allow us to cancel something out and write it in simpler or simplest terms in this case. So the next example we're going to look at is also one out of the book, and this is subtraction. And again, the same thing we're going to do. Let's look at this bottom. Is it the same? 4n minus 32 on both? Yep, it's the same. So we know we're going to have a 4n minus 32 on the bottom. Okay, so we're not going to worry about the bottom right now. On the top, what are we going to do? We're just going to take everything on the top with that minus sign and put everything on the bottom. Now, when you're subtracting and you have multiple terms, I don't know if you remember this, something that you have to keep in mind is pretending this whole thing is in a set of parentheses, because it is. And remember what we learned when we're adding or subtracting polynomials. When you're subtracting, you have to distribute everything. So we need to make sure that we do that. So when we rewrite it, we're going to have a 2n squared minus 30n plus a 16. So we want to keep in mind that little rule that we learned. It doesn't go away just because we move on. That rule is going to pop up every now and then. So if we see this minus sign in front of multiple terms, we just want to remember to distribute that minus sign to everything behind it. Okay, so it's not really something we have to worry about if it was just one term. If it was just the 30n, you would be fine. But because there's multiple terms, that minus sign has to be distributed to each term after it. Okay, so now that we've reminded ourselves of that rule, we want to make sure we remember it. What can we do with everything that we see here? Well, I see a couple things. First of all, I can see on the bottom that I can go ahead and find a GCF on the bottom. But even before I do trinomial factoring on the top, I can find a GCF on the top as well. So let's go ahead and do that. So on the bottom, I can factor out a 4. So if I pull a 4 out, I'll have n minus 8, correct? So 4 times n is 4n. 4 times a negative 8 is a negative 32. On the top, I can pull out a factor out of 2. So I'm going to go ahead and pull out a 2, and in parentheses, I'm going to have an n squared minus 15n plus 8, right? So 2 times n squared is 2n squared. 2 times a negative 15n is a negative 30n. And 2 times a positive 8 would be a positive 16. So everybody's with me so far? So the next thing that we need to do is see what is going to cancel out. So what are we canceling out? Well, I can see that this 2 and this 4 can be reduced. The 2/4 can be reduced to a 1/2. And again, if we have other things that are going to be on the top, that 1 doesn't have to be there. So on top, we're also going to have an n squared minus 15n plus 8. And then on the bottom, we're going to have the n minus 8. So we don't really need that 1 out front. That's not a big deal. If you do put it there for your quizzes or your exam, that's fine. I'll probably just make a note that it's not necessary, but I won't count off for that. So if you need that 1 there to remind you what you're doing, that is a-okay. So our next thing is, can we factor this? So when I look at this, I can see that, well, we're probably not going to be able to factor this because our factor pairs of 8, no matter what they are, they will never equal a 15. So 1 and 8, 1 plus 8 will not equal 15. And then 2 and 4 will not get us a 15 in the middle. So I look at this and I can say, well, that trinomial is prime. I can't factor it anymore. So in this case, there wasn't a whole lot of canceling out that's going to happen. And this is what we're just going to be left with, is an n squared minus 15n plus 8 on top, and then a 2 over an n minus 8. Now, there are going to be times where you do all that factoring and simplification, and then there's really not a lot to cancel out at the bottom, and that's okay. So a lot of your problems on the homework, you will be able to do a lot of canceling out and really reduce it down greatly. But not all of the problems are going to be like that. Sometimes you're going to end up with a trinomial that's prime, that can't be factored any further, and that's okay. So if you get stuck with something like that on the homework, just please let me know. But don't get frustrated if you end up with something that doesn't seem to factor any more than you think it should, because that is something that can happen. All right, so again, adding and subtracting, what do we want to remember? Denominators are the same. So all your homework, that's a step that's already taken care of for you. So then you're just going to kind of combine everything on the top and then factor it through to see what's going to cancel out at the end.